Hey, good morning, everyone. Thanks so much for joining. I really happy to host everyone here with our online meetup number 2. And I know there's a couple people watching right now, but we'll give it another minute. All right, good morning. Yeah, we're going to get started now, and we're really excited to host the second online meetup. We have Colin Bookman here, and he's like a super smart guy. So I said, hey, let's bring him in to talk about AppEngine, since he's got experience with AppEngine and all of that. And we've made a lot of changes with AppEngine over the last decade or so. I mean, AppEngine has been around for such a long time, and we're starting to see different users starting to leverage AppEngine in many different ways. And we're going to go through kind of the latest announcements with AppEngine, and Colin will do a demo with AppEngine as well. Hey, Colin, do you hear an echo?
A bit.
Yeah, so we'll try to control the echo a little bit, but feel free to chat with us on the chat room and ask us questions. We have Vivian here as well, Vivian Nguyen, who's going to be helping with the chat line. I'm Jonathan Cham. I'm a solutions engineer. And Colin, you want to introduce yourself?
Hi, I'm Colin Bookman. I'm also a solutions engineer.
Okay, thanks, Colin. All right, well, let's get started. So just administrative, I think I covered this a little bit already, but chat box is on the side. If you log in, you can definitely ask us questions. You can also email us at gcpmeetup@google.com. And on the bottom right-hand corner, you can adjust the resolution if it's blurry. I know some users have seen that the resolution looks kind of off, and sometimes YouTube will adjust your resolution based on your bandwidth. So if you can't read the text, go ahead and adjust the resolution on the bottom right-hand corner. All right. So actually, Colin, why don't you go ahead and talk about, what is AppEngine, how has it changed, and why would someone use AppEngine versus, let's say, Compute Engine or Kubernetes?
So AppEngine is a platform as a service. And what that means is you just write your application code and you don't have to deal with underlying infrastructure. You specify your runtime or a container, you give it to AppEngine, and as you get traffic, AppEngine will handle the scaling. It will also handle security patches, versioning, and monitoring all your traffic for you. So there's two flavors of AppEngine now. There's AppEngine Standard and AppEngine Flex. AppEngine Standard is the, traditional AppEngine. It runs on our Borg infrastructure. It's limited. It's not very flexible. You can't modify the underlying servers. You can't really bring in native code libraries. But there are some benefits of it. And the main benefit is we can spawn more instances of Standard incredibly quick. The downside is those limitations. Now with Flex, it's basically running on a GCE VM, and it's built within a container. So the benefits of those now is you can really run whatever you want. You can run C#. Anything that runs in a Docker container runs on Flex. As well, it makes your testing better and easier because now you just build a container, you run it in your dev environment, and how it interacts on your dev environment is exactly how it's going to interact on your production environment. And you get a few other small benefits. One being you only have a timeout after 60 minutes versus the traditional 60 seconds, and you can spawn background threads.
Thing I'd like to add is that a lot of customers right now, I mean, they love AppEngine, but they're starting to want to use different runtimes. So, for example, if they have a specific Python version that they want to use, then they're kind of limited with a PaaS offering, right? So the compromise with PaaS is, hey, we're the platform is going to give you everything you need, but if you want to change it, then you kind of lose that flexibility. So, you get scalability, automation, and the compromise is flexibility. If you want to use special runtimes, if you want to go into the VM, if you want to SSH and figure out, which machine, what's running underneath your application, those things is what we're trying to address with Flex, right? So now customers kind of have two choices: Flex, which allows you to control all those things, and the standard, which has been available, for a very long time.
Yeah, another benefit of Flex is think of it almost like a Kubernetes Lite. You don't necessarily want when your early days of your startup or your company or it's a small business app right now, you don't want to deal with the infrastructure. You don't want to have to go and worry about how do you deploy this Kubernetes cluster, how many nodes do I have on it. Flex kind of gives you that path of flexibility that one day you can graduate from AppEngine Flex and move to Kubernetes if that's what you want, or you can stay with Flex and you can scale to massive, massive scales. So how App Engine differs from Heroku and the other offerings is we can scale it. We can scale App Engine to the Pokemon Go size or your Snapchat size. You also get the complete ecosystem of GCP. So all the DevOps monitoring, version control, data store, anything that we offer in GCP is accessible from App Engine. We also have an SLA. So if you purchase one of our support plans, we'll give you contacts 24/7. You'll have a phone number to call. And we also guarantee that it will always have a 99.95% uptime. Also, we dog food it. If you go to quickdraw with Google, it's a cool web page that the machine learning team built, and it will recognize what you draw. So if you draw a smiley face, it will recognize the smiley face. That's all running on App Engine. So because we're using it, we're also finding any issues we find with it, reporting it, and it's a feedback loop. It's also fully managed. You get all our managed services, and it's pretty much no operations.
With Pokemon Go, that's a really good use case because they wanted to focus on their mobile app, and they didn't focus on how do we scale, how do we automate the underlying infrastructure. They just built their app and let App Engine scale out to from hundreds of thousands to millions of users within a couple weeks. And that's why a lot of mobile apps are running on App Engine, because of the fact that they can focus on building and putting value into their software as opposed to the underlying infrastructure.
Yeah, so also background on Pokemon Go, it went from 0 to the size of Twitter within like a week. And App Engine was able to handle that drastic increase of scale with very minimal efforts on Pokemon Go. It was a bit shaky, but when you actually think about how crazy that is from 0 to Twitter scale within a week, it's pretty cool.
Benefit of elasticity, right, is the fact that you're leveraging the cloud to scale out just in case you become the next Twitter or Pokemon Go. But if you don't have to pay for extra infrastructure that just sits around not doing anything.
So time for a quick demo. So this is an App Engine app. There's going to be a bit of lag when it first starts up because we're running on Cloud Functions and there's a bit of warm-up period and it's been idle. But what's going to happen is I can draw on one canvas, and if you give it, sadly, a bit of time because of Cloud Functions, which is in alpha, should hopefully iron out. So basically what this is happening is these two browser sessions are being connected to App Engine over, and they're subscribing to Serverside Events. So when I draw on one canvas, it's sending an HTTP post request to the instance, and then through that PubSub topic, Cloud Functions is getting that data and then sending it back to the other instance and then to this browser. So you pretty much have a Firebase Lite, if you will. And once Cloud Functions is warmed up, you can see it's fairly fast and kind of cool.
Right. And just to emphasize a point here, Colin actually tried to include a bunch of components in this, and although this app is really, really basic, it can scale to a Pokemon Go type of user, number of users, and you'll see it on the back end, kind of using different messaging queues and using Cloud Functions, and he's really built this to like a production-like environment. But yeah, I mean, that's why there's a little bit of warm-up period. We're using some alpha features as well, and I think it'll be really interesting as we go to the next couple slides to see how all this is built.
So with AppEngine, if you want to build your monolith, you can build your monolith, but we always like to say use microservices. It'll make your life easier and it will scale easily. So in this application, what's happening? So the second you go to that web page, you hit a web server and you're just getting some static HTML assets, and that's all this web server is doing. And so this web server doesn't have to worry about, what happens if I have a database connection and it's bogging CPU, and it makes kind of it easier to test, easier to see what's happening. The next thing that's happening is, you go to this web page, you load the drawing. How did that drawing get to your browser? Because, if I refresh it, it would repopulate the drawing from historical drawings. So what's happening is the user is basically subscribing to something called a server-side event, which is new in HTTP 2.0, which AppEngine supports. So how this works is you basically ask our event service, give me all the changes to my given canvas. The event service is then going to query data store, and it's going to ask it for all the drawings that belong to that canvas. And data store is our NoSQL database. That think of it almost like a SQL-lite experience. You can do all your generic SQL queries except for joins. And so it's doing that query on that canvas ID property. It's getting the drawings and it's sending them drawing by drawing as an event to the user as a push. So that user isn't having to make a request, then get a response back and forth. It's a persistent connection. So now this event service also has one other function, which is it can take incoming drawings. So think of the event service as data in, data out. And so the user posts the new drawing. So, I drag my finger, I drew the smiley face. It's a HTTP post to the event service. The event service doesn't need to know how that drawing's handled. It simply just says, send it to PubSub. And the reason you do this is that sooner or later in every application, someone's going to ask you, hey, wouldn't it be great if I could tap into that data stream? And if you write a monolithic application, that requires someone to change the code base, push it to staging, and then change it into production, which for a lot of companies, that could be a month-long process. What PubSub lets you do is it's a messaging queue. So it will hold any message for about comes into a topic for 7 days, and you can have multiple subscribers and subscriptions. So you can have 2 people consuming the topics, and they each get their own copy. And so that basically is where we're putting it. So if you wanted to do analytics with, say, Dataflow or BigQuery and ask, how many drawings do I get in a second? This is a great technology to use.
Talking about PubSub in terms of, what do you need to set up for PubSub? I know with Kafka and things like RabbitMQ, those are messaging queues. And I know a lot of people do complain about setting up the infrastructure, but I think PubSub, you just pointed to an API and it scales out in the back end.
Yeah, so with PubSub, if you want to create a topic, it's one command or one line in your code. It's pretty much no ops, fully managed. It's incredibly simple, stupid to use. And it will also scale, and it's cheap. Like you're talking a cup of coffee for 1 million messages delivered, and it can handle your spikes. So you don't have to have infrastructure for your peak load. You just pay per message.
That's the same for data store, right? You don't really set up any infrastructure. You just point it to an API, and that's pretty much it. It just scales on the back end.
Yep, same thing with data store. You don't have to worry about scaling the data store service. You just kind of give it your data, and you get it back. It's very similar to Firebase for anyone that's used it. You don't worry about infrastructure. You just kind of pay for what you use.
Theme that you'll start seeing not only with Google, but probably with the industry itself is just letting the business focus on the real value, which is your applications and your software running on top, and letting your vendor figure out how to manage the infrastructure, scale it. And especially with Google, we support 1 billion users across 8 apps would be 8 billion users, and that really makes it for us, that's just kind of what we do day to day, right? Is create automation and create platforms to basically be more efficient with everything that we do.
Yeah, and the other benefit with Datastore gives you is it has an SLA to it. It's in multiple regions. You don't have to worry about what if this data center goes down. We've taken care of that for you. And we've also dealt with the consistency restraints that gives, which we'll talk about later. So now what happens, with this PubSub topic? How does it get back to the user? So all the drawings are in the incoming events, and we have a cloud function that basically saves and forwards the drawings. So it takes in a drawing, it saves it to data store, and then it basically finds out what AppEngine instances or VMs are running our event service that need this drawing, and it will forward it to them. And the reason you architecture it this way versus having, say, one topic for every canvas is each of your event instances need to subscribe to a topic. And it's much simpler to subscribe to one topic than to subscribe to some unknown number of topics. So if you have, say, 1,000 users currently connected to one event instance, and each of them are on a different canvas, or trying, canvas, you don't need to have an individual topic for that. It's just one topic, and it does some internal routing. And now, once it goes to those topics, the event services grab the drawing and route it to any relevant users. So kind of like you'll see this theme, if we go back, the web server just serves web assets. The event service takes in drawings and sends drawings to the user. So they're almost like a drawing proxy between the user and our data stores. The cloud function routes the drawings and saves them. And then you'll see it come back to the drawing. So I talk about these HTTP 2.0 server-side events. It's fairly new. Some of you might be familiar with WebSockets, but what server-side events are is it's part of the HTTP protocol where you can basically push events to the web browser without it reconnecting, and it's a one-way kind of server to end user. So it's very much kind of derived off like push notifications or in this case drawings. And the way it works is you basically give an event type and a data payload, and you can have a JavaScript callback that fires off every time a new event comes in. So now to talk a bit more about data store. So data store is a web scale NoSQL database. Like we said, it can scale for your small business app to hundreds of millions of users. And the one thing it gives you is you can query on groups of properties, but you can't join. So like I said, think of it as like a SQLite. You're not able to do the joins, but any other traditional, simple, stupid SQL query you can do on it. But there's some downsides to this. So because the way data store kind of scales to infinite scale practically, it's running on an undefined number of servers across the world. And so because there's a bit of trade-offs you have to do, it's not, it was designed for you can't grow vertically. You have to scale horizontally. And what you get is it's called eventual consistency. So when you write a record to data store, anyone else who queries by key will get that record strongly consistent. So, pretty much there's no race condition. You write it, anyone else who reads it gets the exact same data. But the one weird part is when you do a query, you're querying on eventual consistency data. So if I do that query on, say, where the drawing ID equals X or whatnot, you may get stale data from if you're in a different data center. So take this example. Say you wrote data to node A. It's replicated instantly to node B and C. But say in data center 2, someone does a query right after you write it, and they did the query like 5 milliseconds after the write, they may get a stale record. We do offer ACID transaction support, and there is some ways to get the freshest data, but there's some trade-offs involved. We also offer a StackDriver. So with AppEngine, all your logs and all your notifications are going into StackDriver, and you can do requests on, you can have your phone get a text message if your latency goes above a certain percentage. Or if you start noticing that the error rate's very high, once again, you can get a text message, an email, an alert, and you can monitor all your metrics, as well as with AppEngine Standard, by default, you're going to get a trace. So whenever you get a request, some small percentage of your requests will be basically profiled to see where bottlenecks are. So if you took 100 milliseconds hitting your Cloud SQL or data store or running some image processing, you could kind of see that code trace within StackDriver and get better insights on how to speed up your latencies.
What kind of things do you need to set up in AppEngine for StackDriver to start collecting information? Like, let's say you talked about trace, things like that, and debug. Do you just insert some code into your AppEngine code?
With AppEngine Standard, there's absolutely nothing to set up, which is kind of the theme with Google. Any of our managed services, they kind of work by default. So say in AppEngine, you want to hit BigQuery. The credentials, all that is kind of auto magic. It's already part of the environment. You just kind of say, I want to write that to BigQuery, and it lets you do it because your AppEngine application is running on our infrastructure.
Agent or anything that you need to install?
The agent is by default installed for AppEngine Standard and Flex. So we're also going to talk a bit about the benefits of containers, because with AppEngine Flex, we now allow you to basically upload whatever Docker container you want. And to me, the biggest benefit of a container is consistency. I think every developer's been there at some point in their time frame where they'll run it on their dev machine, they'll give it to their coworker, and it doesn't work. Or you run it on your dev machine, and then in production, there's an error, and you're like, why is this happening? It didn't happen on my computer. And then you find out, oh, you're running PHP version 5.5.3, and I'm running a different version of PHP, and there's some small change within those that cause an issue. Or, oh, you didn't install this dependency, or you're missing this configuration file, or you have one file too many. And so the benefit of a container, it isolates it on an application level. So with your traditional VM, every single VM has its own kernel and operating system. With a container, you basically are abstracting the application. So each container itself can access, networking, it can access the kernel, but its file system is somewhat isolated. So it has each its unique view of its file system, and it runs the application, and that's all it kind of sees. So it's kind of like Golang went around this route. So you kind of bundle all your dependencies, you build a container, and then you don't have to worry about, what files are in the file system. The only files in the file system in your container are the ones you specify. The other benefit to containers is because there's no OS and it shares the OS, you can rapidly deploy your applications. So with your VM, you have to wait for the VM to boot up, then you got to deploy your application, and you got to do all those setups. With a container, you just pretty much run the container and it starts up. And you'll notice with Kubernetes and AppEngine Flex, that's how we can kind of have this very fast auto scaling.
I hear a lot of people talk about microservices and containers and AppEngine. Like, how do those all relate?
So they all relate because if you have a microservice, it's basically you want a single service to do a very small group of things that are very highly related. Now, the issue you face is with microservices, it's traditionally you don't want to scale vertically, you want to scale horizontally. And what that means is in your traditional data center, it's okay to have a 64 core machine with 128 gigabytes of RAM and this big beefy monstrosity. Well, it's expensive. What if you don't need it right then? So with a microservice, you have these stateless, very small services that you can scale. So maybe you have 3 small computers running it off peak, but then on peak, you're going to scale to 100 services. And what you have to do with that is you have to have that ability to rapidly deploy and launch new instances. And this is what the cloud allows you to do is you don't have to have a VM running 24/7 because you're not buying hardware. You're just basically renting it. It's almost like a utility.
That makes a lot of sense. So it seems like with AppEngine, if you're going to write an application to AppEngine, you don't deal with containers, but you're still writing stateless apps because on the back end, the AppEngine platform itself is going to scale out your app and just dump each service, kind of repeat the creation of those services, put it behind the load balancer. Whereas with containers, you actually have to create the container, but you get the flexibility of building your own runtime, using whatever kind of distribution you like in the container. Is that kind of the trade-off?
So with AppEngine Standard, it's your traditional platform as a service. You just basically give it a code base, it uploads it, and it will run it. A lot of our customers have complained about, I want to use blank native library, you don't support it, or, you guys are upgrading your PHP version, I want to stay back on the older PHP version, or you guys don't support Java 8. So because of this, we wanted to give more flexibility. So AppEngine Flex, you have the ability to stay in this platform as a service land where you just give us code and we'll run it. But you also have the opportunity that you can build a container, give us the container, and we'll run it on AppEngine. So you have this, with AppEngine Flex, you have truly flexibility that you can start with a platform as a service. You can then migrate to containers using the same infrastructure, run it on AppEngine, take that container, and one day move it to Kubernetes or GCE or in your dev machine, and you can kind of move it around like that. Hence the name AppEngine Flex.
Flex. So I guess one last question for me, because I'm a dummy. Kubernetes, like in with your experience, if I'm already building my app with containers, I have Docker containers running, like, should I use Flex or Kubernetes? What is your opinion there?
AppEngine Flex is much simpler than Kubernetes. I would say if you're worried about, shaving off 10 milliseconds of latency, or you're requiring that I want to have my application running across the world in every data center to minimize latency, and I'm talking hundreds of instances, Kubernetes might make sense. But it comes at the cost of you have to start dealing with Kubernetes. You have to create a load balancer. You got to deal with traffic and routing. And, when you do an update, how do you deploy it? AppEngine Flex kind of just handles that all for you. So if you don't have a huge DevOps team, I would not recommend Kubernetes.
And so basically with Kubernetes, I still kind of deal with a little bit of infrastructure, whereas with AppEngine, I really don't deal with any infrastructure.
Yeah.
Well, it looks like Colin kind of gave me the sign and said, that's it. I didn't see any questions in the chat room. I would love to just hear a hello or hi if you're listening. One of the great benefits of these sessions are the fact that you can interact with us, ask really tough questions, and be able to give us your feedback. But I look forward to having you in our next session. I think we're going to be talking about BigQuery, and BigQuery is one of my favorite products. So really look forward to seeing everyone there on our online meetup number 3. And thank you very much. We'll stay on the chat room for another minute or so in case anybody has questions. Thank you.
So for managing dependencies on AppEngine, there's a few ways to do it. So if you're running a container, you just build the container, you upload it. You can kind of follow the traditional advice to containers. You can use GitHub or your build tool like Travis. The option with AppEngine Standard, a lot of people will just create a libs folder in their application and kind of check them in to build against. So for the different utilities like Java and PHP, so if you're doing, let's say, custom runtime in Flex, there's different base container images that will have the latest version of Java or the latest version of PHP. But let's say you wanted to choose it. You can choose a Ubuntu or Alpine Linux base distro. Then you can just do your sudo apt.get install Java 8 or Java 6 and specify the particular version, and that will install it. Within AppEngine Standard, the version's not as flexible. So we have a certain number of runtimes. I think like Python, for example, we have like Python 2.5, Python 2.7. That's all we offer. In terms of subversions, you don't have much choice. But the benefit of it is, you don't have to choose. We have a lot of tutorials around AppEngine on cloud.google.com. I personally find our GitHub repos to be a great source because they'll have demo apps. So I believe it's like Google Cloud AppEngine samples, and we'll have them for managed VM and standard. And there'll be like an App Engine standard for an App Engine sample for sending data to BigQuery or using Cloud SQL. And that way you can kind of see, and then you can even run these in your own cloud console of how it works underlying. And then cloud.google.com is much more of a I call it like reference manual. They won't show the full blown, this is an App Engine project, but they'll show you like, how does the app.yaml configuration file work?